Now in this video we're going to look at a difference of two squares. So remember our factorizing checklist. First we're going to look for a common factor, then we're going to look at a difference of two squares, and then in the next video we're going to look at factorizing trinomials. An algebraic expression of the type x squared minus y squared is called a difference of two squares. Now we know that difference means subtraction, so we have two perfect squares separated by a subtraction sign. And when we factorize the difference of two squares, we get two brackets. The two terms are the square root of each term, and we have addition in one and subtraction in the other. So x squared minus y squared equals x plus y upon x minus y. So our first example, we want to factorize x squared minus 36. So we want to check our factorizing checklist, and we're going to look for a common factor, and there isn't one. So now we're going to look for a difference of two squares. And as we've got two terms that are perfect squares separated by a subtraction sign, we have a difference of two squares. So we're going to work out what our perfect squares are by square rooting them. So we have x all squared subtracted by 6 all squared, because the square root of 36 is 6. And we rewrite it as x minus 6 upon x plus 6. Or we can write it as x plus 6 upon x minus 6. Now if we want to factorize 9a squared minus 100b squared, again we're going to go to our factorizing checklist, we're going to look for a common factor. We're then going to see if we've got a difference of two squares, because there is no common factor between these two terms. And we can see that we can square root 9a squared and we can square root 100b squared. There's two terms separated by a subtraction sign, so this is a difference of two squares. So the first term, if we square root it, will become 3a. So we've got 3a all squared minus 10b all squared. And now we're going to write our two brackets with 3a take away 10b in the first bracket and 3a plus 10b in the second bracket to be our factorization. Sometimes we won't have any coefficients, we'll just have multiple variables. Again, if we've got perfect squares, so positive powers, then we will be able to do a difference of two squares. So this time we've got p squared q squared, which will become pq all squared for our first term in each bracket, and we've got jk all squared for the second term in both brackets. So the first bracket will be pq subtracted by jk, and our second bracket will be pq plus jk, which is our factorization of this expression. Now in this example, we are going to have to do two steps. We see that we've got two terms separated by a subtraction sign, but it isn't instantly obvious that we have a difference of two squares. Because first of all, we're going to go to our factorizing checklist, and we can see that we've got a common factor that we need to deal with first. So the highest common factor of 12 and negative 75 is 3. So what we're going to do is we're going to take that in front of our difference of two squares, because if we take out the 3, we end up with 4x squared, take away 25, which is now obviously a difference of two squares. So we're going to work out that difference of two squares by square rooting each of those terms to work out what the first and second terms in our brackets are going to be. Don't forget about the 3. We still have to bring that down because everything is multiplied by 3. So we've got 3, and that's going to be upon the square root of 4x squared is 2x all squared minus 5 all squared. So our complete factorization is going to be our highest common factor 3 upon the first bracket will be 2x minus 5, and our second bracket will be 2x plus 5, and that's our factorization of 12x squared minus 75.